Hello everyone and welcome to a new episode of Svelte D3, the coding series where you can learn how to code data visualizations with the powerful combination of Svelte and D3. Let's jump into our topic for today, which is Phyllotaxis layouts. And yeah, that's a biological name for something which is looking like that, for example. So if you know a couple of my projects, you know that I love Phyllotaxis layouts. It's basically this arrangement of circles in a kind of spiral way, which gives very nice looking patterns. It's also used like in this project that I did a while ago. So Phyllotaxis layouts can be used everywhere in data visualization to arrange data points to build nice looking circular layouts. And today we want to learn how to build them with Svelte and D3. And yeah, for that let's jump into the browser and the code editor. And we start as in my previous videos, if you watched them you know. So I have an app.svelte which is empty, which is our parent component, and today we just work within this component. And well, we have here our main container, which is HTML, where we want to put in our Phyllotaxis layout later on. And I would say, as we're doing like some circular stuff today, let's just grab that main and let's put a nice background on it. So first we have to do a width of 100 view width and height of 100 view height, so that this main container does span the whole space of our page here, so the full wide thing here. And then let's do a background with a radial gradient, and here we could go a gradient from black, which is has an RGB value of 000, to some gray, which is maybe 60, 60, 60. Let's see. That for some reason doesn't work because we need a comma here. So now we get like this radial gradient, which is black in the center and a little bit grayish to the outer parts. So this is of course somewhat responsive. All right, so let's use that for now. Now we have a very nice background where we put circular stuff on it, and we want to basically draw on an SVG. So let's create a new SVG. And today let's not use like X scaling methods or whatever, so let's not make it too complicated with JavaScript. What we can do to have an SVG which is also scaling to our viewport, to our main parent, is we can define a viewbox of 0, 0, 100, 100. That means the top left point in our SVG is 0, 0, and the bottom right point is 100, 100. And we just have to find then coordinates of our little circles that we want to put in here that are within that range. And at the same time we can say, hey, this SVG, let's style it SVG. Let's style it with a width of 100% and a height of 100%. So with that, if I go into our DOM, we see here is main, and then there is the SVG, which also spans throughout the whole space that we have available. So let's just take that for now, and now let's get to the data. So we want to have an array data, and that should have the Phyllotaxis layouted circles. So maybe let's just use 1,000 circles, and we want to do some layout of these circles so that we get these nice clusters, nice looking clusters. And I already brought you this utils.js file, and this utils.js file exports a function which is called layout Phyllotaxis. So for now, let's have a closer look in a second, but for now let's import this layout Phyllotaxis function. So layout Phyllotaxis from utils. there is, yeah, okay, let me just do it like that. So of course we get now an error, stuff like that. So let's make data an empty array for now. Then I can format my file. So wow. So layout Phyllotaxis, and I can use this layout Phyllotaxis function to generate my layouted data. So I can just put in layout Phyllotaxis, and if I open the parentheses, you see, okay, it takes a data array. It is, yeah, and you see here it says any number. So what data any means I don't use TypeScript very often, so at least not in my teaching stuff. This might be for another video, and then you would know that data is an array. So for now, let's just create an empty array. We do array from length 1000. So this is creating us a new array with 1000 empty elements. And now we're having a look what this layout Phyllotaxis is really doing. So layout Phyllotaxis is taking the data, which is an array, and then it takes an options object. And here I have a radius which has a default value of 1. So the radius is the radius of the individual data points. Then we have a radius offset. We'll have a look in a second what that does. We have a spacing, which is 1.5 times the radius. We'll also have a look what that does. And we have a theta, which is obviously some kind of angle, which is 2 times pi, which is like one circle divided by the golden ratio. And the golden ratio is defined here. It's 1 plus the square root of 5 divided by 2. This is around 1.6 something. So this circle here is divided by the golden ratio. All right. What's happening then? So we're creating a new variable layout data, and this is taking the data and it's mapping over the data. So we're going through each element of our data. We're getting like the information of our data, which is in our case just empty because we created an array of empty elements. But we also get I here, which is the number, the ith element in this array. So we get for our 1000 member array, we get here i's from 0 to 999. And then we are, for each of these elements, for each of the data points, we are calculating a local theta. So theta times I means, okay, theta is now this intersection, so this part of our circle, and we multiply it by I. So that means this is defining the angle in the circle where we want to put now the next circle. And then we also define a local radius, which is the radius of this data point. So the data point and its distance to the center of our full cluster of data points. And this is defined by taking the square root of I times the spacing plus the radius offset. So here you can already see that radius offset is something we add to this radius of each of these elements. So this means this is like a distance from the center of our cluster. And spacing is basically the spacing between the individual data points. All right, that's everything. We need the local theta and the local radius. And then we return everything. So if there was some prior information, we just returned it. Then we store the radius. So radius here was initially set to 1. We store it also here so that we can use it for drawing later. And then we calculate the x and the y. And what you see here, the cosinus of local theta times the local radius for x and the sinus of local theta times the local radius for y. This is just recalculating polar coordinates. So polar coordinates, you have an angle, our local theta, and a radius into like the xy coordinates that you need in the SVG for our standard coordinate system, right? So this is done for each data point, and then we return this new array. And I mean, we could just console log this data here to see how it looks like. So if we do a console log here, we get a lot of nice errors. Cannot read undefined, reading radius. Where do you want to read the radius? In utils chase 8. That's interesting now. So in 8, undefined. Well, what's happening here? Could be, no, that should be 1. That's really interesting. Well, what's happening here? I don't know exactly what's happening here. Probably the thing is that radius is reused here. So let's try a thing. Let's say, well, we have here our data, and then we add. Oh, I know what's wrong. I brought you like a wrong function. We have to do this. Yeah, so that's interesting. So that's probably copy paste error, but it's really cool to see what's happening here. So what I really love is you have like for the properties or the arguments for a function that you definitely need, like the data, you put them in here as a direct argument, and then you have this options object here with optional options where you have defaults defined. But the thing is that these defaults are only assigned if you have also a default value for the whole object, and this is an empty object, and this is what I've defined here like that. So this is a really nice JavaScript exercise now, by the way, but okay, cool. So good. We have that, and this is also now working without the empty object. You see it like that. And we could now modify it by saying, well, radius should be 2, for example, and then radius is 2 in the new calculation. But we'll add it here now for the standard values, to a reload here, and then we see here as an array with 1,000 members. And if we look at the contents, we see here objects with an R radius, which is 1, because that's a fixed radius for each of these data points. And then we have an X and a Y, and we can see it centers somewhat around 0. That's because we're getting these negative and positive values for X and Y. Well, it's nice to console log these numbers, but it's better to visualize them. So let's take the data now in our SVG, and now we're using some magical Svelte stuff, which is each data as, and now we could just say, well, as D, but I like to restructure very early, so we're taking out the X, the Y, and the R for each of these data points, and then we close the loop here, and then we say, okay, for each of these data points we are drawing a circle, and then we do a CX, which is the center X of X, and then we do a CY, Y, and then we have a radius R. And for now, we are just defining a fill of white so that we can see something. And then you can see, well, there is now our Phyllotaxis layout. And yeah, it already scales nicely because that's now a property of SVG. So if we have defined the viewbox fixed and we have a dynamic width and height in our CSS for the SVG, then we have automatic scaling, which is quite nice. So we do not need any JavaScript functionalities for that, but it is not centered. So what we need is, we could, it would be best practice to just introduce a group here in the SVG, and then we grab this group in the CSS and say transform, translate 50%, 50%. That means shift everything to the center. And now we're getting our nice Phyllotaxis layout, nicely scaling as well here in the center. All right. It looks a little bit boring with this black and white style, so we could leverage a little bit of D3 to make this more colorful. So what we could use is, let me think, we could use, there are these color interpolators in D3, so let me show you that. So we have this pattern that you could use scale sequential, and then you could insert like a predefined color interpolator, and there are these different ones here. And it's quite nice because a lot of them are perceptually uniform, so you can nicely use them to represent data. And there's really nice ones. I like this interpolate warm a lot, so maybe let's use that. So import interpolate warm from D3. And what was the pattern again? So we need this scale sequential stuff as well. So that's a function which creates us now a nice little interpolator. So what we can do is we could build a color generator, and then we use the scale sequential. And here we can put in as a first argument a two-member array saying a start and an end point of our data set. And here we could say, well, let's take like an array from 0 to data.length -1. So now the interpolator then knows, okay, I want to generate 999 different colors. And here as the second argument, I think we could just put in that interpolate warm thingy. And then we have a color generator, and then we could say fill is not white anymore, but it is color generator. And now we need the index of our data point, and we can grab that here as I and put it in here. And now let's go back, and now, well, you see very nicely that we get now a very colorful Phyllotaxis layout. That's cool. The Phyllotaxis layout has one interesting constant. So let me go back to utils.js. So it was this theta here, which is like the angle that we are advancing from one data point to another. So you could imagine that in polar coordinates, the first data point is set here on the top, and then it moves with math 2 times math.pi divided by a golden ratio. Further, then sets the next point, and then it goes with these distances or angles. And we could also use some other number as the golden ratio. I mean, we could just put in something like 1 here, then everything like is on one line. We could also put something on here which is not exactly 1, and then you can see that there are different piles coming up. And the problem is if you have rational numbers like 1.1 or like ending numbers like that, 1.13, then you run into these problems that you have very regular layouts. But if you use irrational numbers, then you get these nice effects. And I have 2 others here on top. There is some irrational numbers that you also get from some D3 examples. So let's take this irrational 2 here, and then you get this very static, nice looking spiral layout. You could also use the irrational 3 here, then it gets a little bit more defined. Yeah, that's it basically. But for now, let's go back to the golden ratio. Yeah, then I told you that we could also play with the spacing. So here the standard spacing is radius times 1.5. We could also use 2.5. Then you see that there is much more space between the individual circles. And we can also play with the radius offset. So if I multiply that by 10, for example, you can see that I get like this hole in the middle where everything has more distance to the center of our cluster. But you can also just use these standards, and as I said before, you can also pass in like different properties here. So if you want to have now a radius of 2, for example, you could just do it like that, pass in an object where a radius is defined, and then you get like this larger radius here. Okay, cool. We leave it with the standard options, and that's basically it. And as a last little feature, we want to visualize now a little bit how this whole thing is drawn. So we want to highlight the first circle, then we want to highlight the second circle which was drawn, and so on and so on. I mean, it is already highlighted by the color a little bit, but not exactly. So what we could do, we could just say, let's say there is also a fill opacity, and we say if I, so our circle is like an active circle, so we do not, active circle index, so we do not have that variable yet, then we say fill opacity is 0, otherwise fill opacity is 1. So this active circle index, let's define it. Let active circle index is 0. And here is a typo. And then you can see that like the first circle is gone, and now I can set up an interval and just say, well, increase active circle index by 1 every 700 milliseconds. So let's do that. And now you can see that the circle is kind of highlighted. Well, it's disappearing right now. So maybe we should add a stroke as well. So we do a stroke which has the same color. By the way, this is not looking very nicely. You have color generator 2 times. So what? Let's first do the stroke. Well, that is really thick. So let's do stroke width equals 1 pixel. Let's see if that works. No, this is already 1 pixel. It is 1 pixel if we have like an SVG of 100 times 100 pixels, but here we are already scaling up. So if I make this smaller, then we have the 1 pixel stroke width. So with the scaling, we could maybe do 4 or 5.5. 0.4, and then I think now our circles are very narrow to each other. Now we could say, well, let's do a different spacing. Let's say we want to have a spacing of 2. Oh, that's a little bit too much. 1.7 maybe. Yeah, 1.7 is fine. And yeah, now we see how these circles are drawn. So you can see now that it's moving on with the local radius. So the local radius again is the distance of the individual circle to the center of our whole cluster. And you can see how the algorithm progresses with the angle, which is always the same, which is like math.pi, so pi times 2 divided by the golden ratio. And now we have this bad thing that color generator I is invoked 2 times per circle. This is not really nice. And here you can do something with Svelte, which is the add const stuff, which is defining the color with color generator I. So with that you can define a local variable within an each block. And now this is only invoked once. Pretty nice. That's how it works, and this is how you build these nice Phyllotaxis layouts. Thank you very much for watching, and see you next time. Bye.